Good day. This video is all about operations with whole numbers, meaning we are going to add, subtract, multiply, and divide. But before we do that, let's quickly recap a bit of our characteristics of a 0 and 1. The first thing, 0 is the identity element of addition. What does that mean? It means that if I add 0 to any number, the number will stay the same. For example, 5 plus 0 will give me an answer of 5. So the identity of 5 stayed the same. It is still a 5. Another characteristic of a 0, if I multiply any number with 0, the answer is 0. If I divide 0 by any number, for instance, 0 divided by 5, what should the answer be, or what will the answer be? 0. But if I divide any number by a 0, for instance, 5 divided by 0, what will the answer be? 0. No, this answer is undefined. Some characteristics of the 1. 1 is the identity element of multiplication. What does that mean? If I multiply any number with a 1, let's do that. 5 times 1. The answer remains 5. So the identity of the 5 did not change. Another thing about the 1. If I divide any number by 1, for instance, 5 divided by 1, it also stays as 5. Right, now that we have quickly had a look at the characteristics of the 0 and the 1, let us do some operations with whole numbers. Let's start with addition. Example 1. I have 6,283,941 and I need to add 15,763 to that. Bear in mind that it's very important that you write the units, the tenths, the hundreds underneath one another. So it should be 15,763. Okay, what's my answer? How do I go about to do that? Boys and girls, you have done these types of questions already from grade 1, 2, 3. Okay, I know this might be now a longer number in the first place, but it doesn't matter. You just apply the rules that you know. 1 plus 3 is 4. 4 plus 6 is 10. So what do? You write the 0 and you carry over the 1. 1 plus 9 is 10, plus 7 is 17. 1 plus 3 is 4, plus 5 is 9. That's also 9. The 2 and the 6 remain there. So my answer will be 6,299,704. If I do example 2, and now I'm going to subtract. So I'm going to use my same values, but I will just now subtract. How should I do that? Again, it's very important that you keep the numbers, the place values, underneath one another. So 6,283,941 minus 15,763. Okay, how should I go about it? 1 minus 3, you can't. So you need to go and borrow. I borrow 1 there, or actually you are borrowing a 10. So I put it there, but this is remaining now 3. So 11 minus 3 is 8. 3 minus 6, again you can't. Go and borrow, so that becomes 8. So it's 13 minus 6 is 7. 8 minus 7 is 1. 3 minus 5, you can't, go and borrow. So that becomes 7. So it's 13 minus 5 is 8. 7 minus 1 is 6. 2 minus 0 is 2. And 6 minus 0 is 6. 6,268,178. Okay. Now, let's do example 3 now, the multiplication. Okay. We are going to multiply 3,941 times 628. Now, boys and girls, maybe you have learned a couple of ways in which you can multiply. I'm going to show you 2 ways. The most common way and then a very nice and interesting way. Right, let's do it in the first way, the first method. 3,941 times 628. Please make sure for you to help yourself that you put the units underneath one another, the tens underneath one another. Place values are very important, especially when you multiply. Well, actually always, but it's very important. Okay, we start from the back. 8 times 1 is 8. 8 times 4 is 32. So 32. 8 times 9 is 72. And 72 plus the 3 will be 75. 75. 8 times 3 is 24. And 24 plus the 7 is 31. Okay. Now I've dealt with the 8. I'm going to go to the 2. But that 2 is actually 20. So that's why we put a 0 here to realize or to show that we are multiplying with 20. And then we can just say like we are now multiplying with the 2 because we already have the 0 there. 2 times 1 is 2. 2 times 4, 8. 2 times 9, 18. And 2 times 3 is 6 plus the 1 is 7. Okay, now the 6, or actually the 600. So we put 2 zeros to realize that we are multiplying with the 600. 6 times 1 is 6. 6 times 4 is 24. 6 times 9 is 54, plus the 2 is 56. 56. 6 times 3 is 18, plus that 5 is 23. Okay. Now let's add them. 8. 2 plus 2 is 4. 5 plus 8 is 13. And 13 plus 6 is 19. 1 over. 1 plus 1 is 2, plus 8 is 10, plus 4 is 14, 1 over. That's 4, and 6 is 10, plus the 7 is 17, 1 over. It's 4 and the 2. So your answer will be 2,474,948. Right, this was the ordinary method, the column method. Now I'm going to show you a very nice method. And this method goes by many names. It's going by the name of Chinese method, Italian method, Galotia method, and also ordinary lattice method. So I'm going to show you how to multiply this by doing it in a lattice. I have a 4-digit number multiplied by a 3-digit number. So that's why I'm going to draw a lattice of 4 by 3. Okay, so the 3, 9, 4, 1, and 6, 2, 8. I'll write it like that. Now, very important, I'm going to half each square in my lattice. Okay, now see if you understand how this works. I will say 6 times 1 is 6. Now, each little square represents kind of, if you think about that, units and tenths, okay? So 6 times 1 is 6 units, but 0 tenths. 6 times 4 is 24. So it's 24. 6 times 9 is 54. 54. 6 times 3 is 18. Let's do the 2. 2 times 1 is 2. 2 times 4 is 8. So 0, 8. 2 times 9, 18. 2 times 3, 6. The last one, 8. 8 times 1 is 8. 8 times 4 is 32. 8 times 9, 72. And 8 times 3, 24. Now, once you have the completed letters, it's now important that you add the diagonals to build your number or your answer. So in this one, I'm going to read it like that. There's an 8. Then in this one becomes 4. That diagonal there, 6 plus 8 is 14, plus 3 is 17, plus 2 is 19. But now you need to take it 1 over. You need to take the 1 to the next diagonal. So I'm going to do that now. 1 plus, that's not a 10 now, guys. That's not a 10, it's a 1. 1 plus 4 is 5, plus 8, 13, plus 7, 20, plus 4, 24. The 2 over. 2 plus 2 is 4, plus 4, 8, 9, plus 6, 15, plus 2, 17. 1 plus 5 is 6, plus 8, 14. 1 plus 1 is 2. And let's check to see whether our answers are actually the same. 2,474,948. Yes, we did it the same. Okay. The last operation that we are going to do with whole numbers and the last example will be division. So let's have a look at example number 4. I'm going to divide and I'm going to write it already in the way that you know. 13,947. 13,947 be divided by 28. This is example 4. Okay. Right, guys, once you need to divide by a number that is this big, it is much easier if you have the multiples of that number on the right-hand side. Then you can quickly solve the problem. So I'm going to think now for myself by saying 1 times 28 is 28. 2 times 28 is 56. Okay, let's make an arrow. 3 times 28 will be 84. 4 times 28, then you add another 28 there. So that will be 112. 5 times 28, 140. 6 times 28, 168. 7 times 28, 196. 8 times 28, 224. 9 times 28, 252. You only have to do up till 9 because if you have to do up to 10, that's not going to work like that, okay? You will not have it be able to divide into that more than 10 times. Okay. Now, once you have this, it's very easy to do the calculation. So I want to say 28, and usually we can now say, can 28 go into 1? No, it can't. Can 28 go into 13? No. Can 28 go into 139? Yes, it can. How many times? Go and have a look here. 139. I have 140. It's not enough. I have 139, so it can only go into that 4 times. So 4 times 28 is 112. Again, once you have that, it's so much easier completing your division calculation. Let's subtract now. 9 minus 2, 7. 3 minus 1 is 2. 1 minus 1, it's 0. Right, once you've subtracted, you bring down the next value, that 4. Now you have 274. How many times can 28 go into 274? Let's find it here. Where does 274 lie? There. It's at least 9 times. So 9 times 28 will give me 252. And once you've subtracted that, what's your answer? 4 minus 2 is 2. 7 minus 5 is 2. 2 minus 2 falls away. Bring down the 7. You have 227. How many times can 28 go into 227? Let's find it. 227. At least 8 times. Now that was, maybe you can't see that well, but it's 224. So it can go into that 8 times. 8 times 28 is 224. So what's remaining? A 3. So what's the answer now? You can now say it's 498, remainder 3. Or you can say the answer is 498. And now, boys and girls, watch what I'm doing now. And 3/28. Okay. And 498, careful here. 498 and 3/28 is not the same than 498,3. It's not the same. Okay. So you can also write it like that. I do hope that you have now quickly recapped it with me and you understand what we have done. And please, again, and I've said this many times before, maths start by knowing your times tables. Until next time, goodbye.